So I said what is an abstract method is. So abstract classes and abstract methods. To work with these abstract classes and abstract method, Python provides one predefined module. What is the name of the module? ABC module for implementing abstract classes and what methods. It is a predefined module which comes with what Python software. Now using abstract classes and abstract methods, we can implement what? Polymorphism. I said what is an abstract method? I said what is an abstract method is. I said what is an abstract method is. Abstract method is object level method or instance method. So abstract method defines a protocol or rules and regulations which has to be implemented by every derived class. I said abstract method defines the behavior of derived class or child class. Abstract method doesn't have implementation in which class? Base class. So abstract method is which method? MD method. Because it just define only the rule. Yes. But if you want to declare a method as an abstract method, if you want to declare a method as an abstract method, you are using one decorator. What is a decorator you are using for declaring method as abstract? @ abstract method. So you are writing a method name and this is self. Yes. But where you can write an abstract methods only in which class? Abstract class. So what is abstract class? Abstract class is a collection of abstract methods and non-abstract methods. You can say abstract class is an abstract data type. You can say abstract class is which one here? Abstract data type. A data type which allows a data type which allows to build similar data types is called as which one? Abstract data type. Okay, an abstract class is used for inheriting, but you cannot use it for creating which one? Object. So this is a syntax of writing which class here? Abstract class. Okay, so abstract class is used for developing similar type classes. Okay, or it is used for developing similar type data types. So for example, so what you're doing is, so to declare a class as an abstract class, I'm using ABC module. So I'm just writing A is a class, but A is which class here? Abstract class. Okay, otherwise. Okay, assume that there is a class. What is a class here? Animal. So animal is which class here? Abstract base class. So what animal define? Abstracts. Abstract means the behavior of animal without dictating what? Implementation. So I'm writing here abstract method. So there is a method called animal is what? Eat. You are just writing what is the behavior of animal, but without dictating what here? Implementation. You are just defining the behavior of animal without dictating implementation. You are saying that okay, animal what? Eat, but you are not telling what it eat. So that might be changes from one animal towards another. For example, there is an animal called which one? Dog. Dog is a, what is this here? Animal. Dog is an animal. Okay. And overrides. So override which method here? Eat method. And you're writing here print. What you're saying, dog eat. So dog eat non-veg. Okay, so there is another animal which is called as cow, is an animal and is having a method called eat. And here I'm saying cow eat. What is that here? Veg. But here using animal, I try to build how many animals here? Two animals. So is it this you can call it as which method here? Overriding method. This is called as which method? Overriding. This is called as which method? Overriding method. You are trying to override the method of which class? Base class. In which class here? Derived class. So you cannot create object of animal. You cannot say A1 equal to animal. If I'm writing A1 equal to animal, so this will give error. If I'm writing A1 equal to animal, this gives what here? Error. You get an error here. If you run this, ABC dot, what is the class name? ABC. So if you run this, it is given error saying that type error. So cannot instantiate abstract class animal with abstract method what here? Eat. Because abstract class is only abstract. You cannot create object of which one? Abstract. You cannot create animal. But you can create animal like dog. You can create object of which one? Cow. But you cannot create object of which one? Animal. Because animal is what here? Abstract. Animal is an abstract and you cannot create object of which class? Animal class. But you can able to create an object of which class? Dog class. I can say dog 1 equal to dog. I can say cow 1 equal to what here? Cow. I can say dog 1 dot eat. And I can say cow 1 dot. What is that? Eat. So when you declare, now you can see dog eat non-veg and cow eat what here? Veg. So when you declare the method as an abstract in base class is when more than one subclass, when more than one subclass having similar role with a different implementation, when you declare the method as an abstract in base class, okay, when you declare a method in base class as an abstract is when you declare a method as a abstract in base class is when more than one method, when more than one method or when more than one derived class having similar role with a different implementation, with a similar role with a different implementation, when more than one derived class having similar role, but the implementation is what? Different. So then inside base class, that method declared as what here? Abstract. So inside the base class, you declare that method as what? Abstract. suppose if you take Suppose if you take an example like this, for example, there are two objects out there. Okay, assume that there are two objects here. Okay, assume that there are two objects out there. These are the two objects. So there is one object. There is one object called which one? Triangle. So there is an object called what here? Triangle is object. And triangle is having two dimensions. So that is dimension 1 and dimension 2. Now which you can call it as base and height. Triangle is having two dimensions, that is dimension 1 and dimension 2. And you are reading the dimensions of this triangle by using one method called which one? Redimension. Using this method, you are reading the dimension of triangle. Okay. Using this method, you are reading the dimension of triangle. Using this method, you are reading the dimension of what? Rectangle. So there is one more method called which one? Find area. So using this find area, you are finding the area of what? Triangle. So you are trying to say dimension 1 into what is that? Dimension. Okay, these variables are instance variables. Assume that. Okay. So this is which one here? Triangle. So there is one more object is there. What is that? Another one? Rectangle is there. So rectangle having two dimensions, that is dimension 1 and what? Dimension 2. Okay. And you are reading this dimension 1 and dimension 2. You are reading this dimension 1 and dimension 2 using a redimension. Where I'm saying dimension 1 equal to float of what I'm saying here input. So input the dimension 1. So there is a read dimension, and this read dimension is trying to read the dimension. So float of, I'm saying what here? Input. You're trying to input the dimension 1. You're trying to input the dimension 1, and you're trying to input what here? Dimension 2. And there is a method called find area, and this will find the area of which one? Rectangle. So where I'm saying dimension 1 into what? Dimension 2. Now suppose if you see this both the classes like triangle as well as what? Rectangle. Now these classes will share the same properties or not? Yes. Triangle is having two dimensions and rectangle also having two dimensions. The way how you are reading the dimensions of the triangle, in the same way you are reading the dimensions of what? Rectangle. It means is it this both the classes are sharing the same properties and behavior or not? Yes. Then what do you do it? You write these properties how many times here? One time. You write this how many times here? One time. So you are trying to develop one class called which one? Shape. There is one class. What is the name of the class here? Shape. Now shape is a class, and shape is having how many dimensions here? Two dimensions. So that is a dimension 1, and one more is what? Dimension 2. Now shape is having two dimensions, that is dimension 1 and dimension 2. Okay, then now suppose triangle. Triangle is derived from which one? Shape. So where you can say triangle is a, where you can say triangle is what? Shape. And even rectangle also derived from which one? Shape. Then you can say rectangle is a, rectangle is also what here? Shape. So it means triangle inherit how many variables? Two variables. Then is it required to write again? No. And rectangle also inherit this two variables from where? Shape. Means every shape is having how many dimensions? Two dimensions. Triangle is having two dimensions and rectangular also having two dimensions. Then you write one method here. You write one method here, that is what? Read dimension method. So you write a read dimension method. This is used for reading the dimensions of shape. Reading the dimensions of shape. So that is dimension 1, and one more is what? Dimension 2. So it means you are reading the dimension 1, dimension 2 of the shape. It means this read dimension method of shape is inherited in what? Triangle. So if you want to read the dimensions of the triangle, you'll try to use which method? Read dimension. If you want to read the dimensions of the rectangle, you'll use which method? Read dimension. So how many times you declare these variables? One time. How many times you define this method? One time. And this way are used by how many classes? Two classes. One is triangle and one more is rectangle. This method is used by how many classes? Two classes. One is triangle and what? Rectangle. But every shape also having one more method. What is that method? Find area. But is it implementation of this find area is the same? No. Implementation of find area is not same here. Implementation of find area is what? Not same here, right? Implementation of this find area is not same. Implementation of find area is what? Not same here. But every shape is having which method? Find area. Every shape is having find area, but implementation of this find area is not same. So when more than one subclass or derived class having same role is the same, method is the same, but implementation is the same or different? Different. Then you declare that method as what? Abstract. Then you declare that method as what here? Abstract. You declare that method as an abstract in which class? Base class. So which method is an abstract here? See here, which method is an abstract here? Which method is an abstract here? Find area method is a abstract. Why you declare the find area as an abstract? Because implementation of this method is the same or changing? Changing. Implementation of this method is the same? No, it is changing from one derived class toward another. Implementation of this method is changing from one derived class to another. Implementation is not same, right? Then you declare that method as what? Abstract. Means every shape must provide the implementation of which method? Abstract method. So is it these are called overriding methods or not? Yes. So abstract method must be override. Abstract method must be override in which class? Derived class. If abstract method is not override in which class? Derived class, then it gives what? Error. If abstract method is not override in derived class, it gives what? Error. See here, we'll just implement this program. Now import which module here? ABC module. And there is a class called shape, but I cannot create a shape. I cannot create the object of what? Shape. I cannot create the object of shape. Okay, remember this. I cannot create the object of shape. Okay, I cannot create the object of shape, right? I cannot create the object of shape, but I can able to develop what? Different shapes. I cannot create object of shape, but I can develop different shapes. Right? Now here, every shape is having some properties. Now I'm trying to write with a single underscore. If it is double underscore, it is what? Private. If it is single underscore, it is what? Protected. This variable is what now? Protected. Dimension 1 is a protected. And protected variables are accessible only in which class? Derived class. Public variables are accessible within derived class as well as outside the class. But protecteds are accessible only within what? Derived class. In the same class as well as in what? Derived class. If it is with single underscore, then it is called as what? Protected. If it is a double underscore, it is what? Private. So this is called as which variable now? Protected variable. This is also protected variable. So where I can use this protected properties? Only within the class and within the derived class, but not outside the derived class. Not outside the derived class. So there is a method. What is the name of this method? Redimension is a method. So what is the name of the method? Redimension. So this will read dimensions, right? Input, enter dimension 1, self dot. Okay, dimension 1 and this is dimension 2, and float of input enter what is that? Dimension 2. So read dimension is a method. So this will read the dimension 1 and dimension 2 of which one? Shape. And there is a method, and this method is which method? Abstract method. So what is the abstract method here? Find area. Find area is an abstract method. An abstract method is an empty method or not? Yes. Abstract method is what here? Empty method. This method is empty now. This method doesn't have any implementation in the shape. So why this method is empty? Because this implementation is provided in which class? Derived class. But this method doesn't have implementation in which class? Shape class. But this method can have the implementation in which class? Derived class. So what is a derived class here? Now shape. And there is a shape called which one? Triangle. Triangle is a shape here. And this triangle will override. This triangle override which method? Find area. So this find area is which method now? Overriding method. Find area is which method? Overriding method. And this will return. What it returns? Self dot dimension 1 and 2. What is that? Dimension 2. But it should also inherit the properties. For that, I need to write which one? Constructor. And this constructor should call the constructor of which class? Super class. And you can call it by using super, or you can call it by using which name? Class name. Okay. Yes. This is a triangle. And there is another class. What is it? Another class here? Rectangle. And rectangle is also what here? Shape. So triangle is a shape and rectangle is also what here? Shape. And rectangle is having what here? Init. And this will call the init method of which class? Super class. This will call the init method of which class? Super class. And then it override. It override which method? Find area. Now, dimension 1 dot self dot dimension 2 into 0.5. So find area method override. And then I'm saying return self dot self dot dimension 1 into self dot. What is that here? Dimension 2. Now this is nothing but length into what here? Breadth. And this is nothing but off into base into what? Height. Okay. But implementation of this find area is the same or different? Different. So then you declare this method as what? Abstract. But is an implementation of this read dimension is the same or different? Same. The way how you are reading the dimensions of the triangle, the way how you are reading the dimensions of the triangle, in the same way you are reading the dimensions of what? Rectangle. So when the more than one derived class having same implementation, then you write that method with what? Implementation. But here you write a method with what? Without implementation, because this implementation is not same. What should I write in shape? Is the shape is having, is it any formula for finding the area of shape? No. There is a formula for finding the area of which one? Shape called triangle. There is a formula for finding the area of the shape called which one? Rectangle. But every shape is having which one? Area. So that implementation might be various from one derived class to what? Another. Then I cannot create shape object, but I can create which one? Triangle. I can create triangle and I can say triangle 1 dot read dimension. I can say area 1 equal to triangle 1 dot. What is that here? Find area. So then I can create a rectangle by saying rectangle 1 R1 equal to rectangle. So I create which object? Rectangle, and rectangle 1 dot. I read what here? Dimension. Then area 2 equal to rectangle 1 dot. I'm finding which one? Area. So this is what I'm doing it. Right after that, I try to display area format area 1 with how many decimal places? 2 decimal places. And displaying area 2 with how many decimal places? 2 decimal places, right? So once you run this, now it's asking to enter the dimension 1 of the triangle 1, dimension 2 of triangle, and this is dimension 1 of rectangle and dimension 2 of what? Rectangle. You can see 0.78 and 2.10. I said, abstract classes are nothing but which one you can call it as abstract data types. It is called as an abstract data type. Means a data type which allows you to build a data type which allows to build similar data types. A data type which allows to build similar data types. Okay, that data type is called as which data type? Abstract data type. So that is called as an abstract data type. For example, so that you can call it as abstract data type. For example, there is a, okay, assume that there is a class. Already you have a class called which one? So there is already a class which is already exists. What is the name of the class here? List. List is a class which is already exists. Okay, list is a class. Okay. Now what do you do it using a list? You try to develop different types of lists. Okay, using a list, you try to develop different types of lists. Using a list, I develop a list called which one? Stack. Using a list, I develop a list called which one? Queue. Now stack is a list. Okay, stack is a list, but it follows which one? Last in, first out. And queue is a list which follows which one? First in, first out. Stack is a list which follows last in, first out, and queue is a list which follows the first in, first out. You override the methods. You override the methods of list inside what? Stack. You override the methods of list inside what? Queue to perform certain operations or not? Yes. So abstract class. Now just try to understand what is abstract is. Abstract will define some set of rules and regulations. Abstract will define some set of rules and regulations. Set of rules and regulations. For example, suppose there is an abstract. There is an abstract. For example, there is an abstract called which one? Debit card is there. For example, debit card is an abstract which are given by which one? RBI. So RBI gives what here? Abstracts. RBI is given abstracts how to develop which one? Debit card. RBI tells how to develop a debit card and what functions the debit card should have it. Okay, how to develop a debit card and what functions a debit card should have. So those things are defined in what? Debit card. Okay, those content is developed in those content is defined in what? Debit card. So assume that debit card is having number, CVV and all the things. Apart from that, assume that there is debit card should also have one method called which one? There should be one abstract method. In debit card, there is an abstract method called which one? Withdraw. So withdraw is an abstract. Why? Because this withdraw implementation might be various from one bank to what? Another bank. Okay, the implementation of this withdraw, the implementation of this withdraw might be various from one debit card to what? another debit. Now, who's given the abstracts here? RBI. It means debit card is an abstract or not? Yes. Debit card is an abstract which defines some set of rules and regulations. And by following these rules and regulations, you'll try to develop which one? Debit cards. Okay, suppose there is a bank. Okay, there is one bank called SBI is there. Now SBI want to develop debit cards. SBI want to develop which one? Debit card. Then how SBI develop debit card? By following the rules given by whom? RBI. Okay. How SBI develop a debit card? By following the rules given by RBI. So SBI debit card is developed. SBI debit card is developed by following the rules. SBI debit card is developed by following the rules given by which one? RBI. So it means SBI debit card is a type of which one? Debit. In the same way, there is another bank is there. Okay. There is another bank called some assume that there is another bank called suppose SDFC is there. This is which debit card here? SDFC debit card. So SDFC debit card is a debit card again. SDFC debit card is a debit card. Okay. So SDFC debit card is developed by following the rules given by whom? RBI. So here you try to override. What you override here? Withdraw. And provide the implementation. Means in SBI, what rules are there for withdrawing it? Okay, SBI allows to withdraw this many number of transactions like that. Okay, now there is a rule inside what? Withdraw. Which one? SDFC having different implementation. Okay, behavior is the same, but implementation is what? Different. Role is the same, but implementation is what? Different. Assume that SBI allows to withdraw some 20,000 or 30,000. SDFC allows to withdraw some 50,000 or 60,000. But is it implementation is the same or different? Different. But behavior is the same, role is the same, but implementation is a different. Then you declare that method as what here? Abstract. Abstract. But by using this abstract methods, you can achieve, okay, with the help of this abstract classes and abstract methods, you can achieve what here? Using this abstract classes and abstract methods, you can achieve runtime polymorphism. Let us see this example here. Okay, now there is a import. What is that? ABC module. And there is a class. What is a class here? Debit card. Debit card is a class. And debit card is which class? Abstract base class. Means I cannot create object of which one? Debit card. So this is having an abstract method. This is having an abstract method. This is having an abstract method called which one here? Withdraw. This is having an abstract method called what? Withdraw. So debit card is an abstract base class and having abstract method called which one? Withdraw. So there is a debit card. What is a debit card here? SBI debit card is a debit card. And provide the implementation of which one? Withdraw. So here I'll say withdraw of withdraw which one here? SBI. I'm not writing any other logic. So there is another debit card. What is that? SDFC debit card. SDFC debit card is also what here? Debit card. And provide implementation of which one? Withdraw. So abstracts are given here. Now withdraw. This is withdraw of which one? SDFC. Withdraw of SDFC, right? Now this is called as which method here? Overriding method. This is called as which method? Overriding method. So abstract method must be override. If you are not overriding an abstract method, abstract method must be overridden override in which class here? Derived class. Abstract method must be override in which class here? Derived class. If you don't override this abstract method in derived class, you cannot create even object of which one? SBI debit card. No, because again SBI debit card also becomes what? Abstract. Because of that, derived class must override all abstract methods. Derived class must override all abstract methods. Okay. Now I create card 1. So card 1 is which debit card here? SBI debit card. Okay. And card 2 is there. Okay. Card 2 is which debit card? SDFC debit card. Then I'll say card 1 dot. What is that here? Withdraw. I'll say card 2 dot. What is that here? Withdraw. Card 1 dot withdraw and card 2 dot what? Withdraw. So I call the withdraw method of which one? SBA. I call the withdraw method of which one? SDFC. Okay. Now if you run this, you'll get a message. If you run this, now you can see withdraw of SBI and withdraw of which one? SDFC. But both are developed by following the rules given by which one? RBI. But what is the advantage of this? Okay. What is the advantage of this is? So what is the advantage? So what is the advantage of this is? Okay. So the advantage of runtime polymorphism, the advantage of method overriding is, what is the advantage of method overriding is achieving which one? Runtime polymorphism. Runtime polymorphism, or same thing you can call it as what here? Duck typing. So to achieve runtime polymorphism, or the same thing you call it as which one? Duck typing. It's called as runtime polymorphism. Okay. That you read yesterday's notes. Navin, if you are there, Navin, you are there? Navin Reddy. Okay, Navin Reddy, are you there? Are you there? Yes, yesterday you are absent. Yesterday you are there or not there? No. Okay, very good. You are not there, then how here? Okay, now. Then, okay. If you are not there, what should I do now? Yesterday you said no, now you are saying yes. Huh? You said no, sir. Yesterday I am present. You are not present. You are absent yesterday. Yesterday you are not present, I think. You are present. Where is this? Where is the decorator? Where is this ABC? ABC. What I said ABC. ABC is there. No, ABC is what? Yesterday you are there. No. What is ABC? ABC is what? Yesterday you are there. What is ABC? ABC means don't say alphabets. And both there like here you open the notes and start seeing means it will take a lot of time. ABC is there. We started with what here? Abstract. What we have seen? What I said here? Python provide which module? Which module here? ABC module for implementing which one? Abstract classes and methods. So where is this decorator is in? Where is the decorator abstract method is in ABC module. Where is this ABC class is in ABC module. If you want to use anything, you have to import or not. Okay, na? Right. So runtime polymorphism. So what is runtime polymorphism or duck typing? So this allows you to develop some loosely coupled code. Now this is duck typing definition given by Python. So this is a duck typing definition given by the Python here. What is duck typing here? So a programming style which does not look at objects type, a programming style which doesn't look at object type to determine if it has the right interface. Instead, the method or attribute is simply called or used. Method or attribute is simply called or what? Used. If it looks like a duck and quacks like a duck, it must be what? Duck. It looks like a duck and quacks like a duck, it must be what? Duck. By emphasizing interfaces rather than which one? Specific types. The same thing you call it as runtime polymorphism is nothing but an ability of reference variable. What will happen is an ability of reference variable, okay, change its behavior based on change behavior, change an ability of reference variable changes behavior based on the type of object assigned. The type of object what assigned. An ability of reference variable changes behavior based on the type of object assigned is called a runtime polymorphism. So runtime polymorphism allows to develop okay, loosely coupled code. Okay, the code which work with what is that? Any type. The code which work with any type, that code you call it as which code? Loosely coupled code. So the same thing is called as even duck typing, or it is also called as which one? Runtime polymorphism. So what is the meaning of this is, we'll see one application. There is a class A is there. Class A is having one method called M1. So this is M1 of which class? A class. There is a class B also having which one? M1. But this is M1 of which class here? B class. Okay. So see here. Now this is duck typing. A programming style which doesn't look at an object's type to determine if it has a right interface instead of the method or attribute is simply called or used. If it looks like a duck and quacks like a duck, it must be what? Duck. It looks like a duck and quacks like a duck. Now both are having same method or different method? Same method. Okay, is it both are having same method or different method? Same method. Same method means it, this A and B look like what? Duck only. Okay, A and B both are what now? Ducks only. A is a duck and B is a duck. Okay, and it is having same methods, but implementation is what here? Different. Method is the same, but implementation is what? Different. Okay. Yes. For example, see what is a runtime polymorphism is, I create object of which class? A class. I create object of which class? B class. I created object of A class. I created object of which one? B class. For example, there is another variable called objx. Suppose I assign obj a to what? Objx. It means objx is holding which object? A object. And if I say objx dot m1, then it will call which method? M1 method of which class? A class. Suppose if I'm assigning objx which one? Objb, and if I say objx dot m1, then it will call m1 method of which class? B class. It means the behavior of this objx, calling of this m1 method of objx is changing based on the object what you assign it or not. Yes, if you assign a object to the objx, then it is calling m1 method of which class? A class. If you are assigning b object to the objx, it is calling m1 method of which class? B class. It means the behavior of this variable is changing based on which one? Object assigned. Behavior of this variable is changing based on the type of object assigned. So this is very much useful when you're developing some loosely coupled application. I'll tell you, like where exactly this runtime, where exactly this runtime polymorphism is used. For example, but in this case, when you assign a object to the x, it is calling m1 method of what? A. When you assign b object to the x, it is calling m1 method of what? B. Okay. When you are assigning a object to the x, it is calling m1 method of what? A. When you are assigning b object to the x, it is calling m1 method of what? B. It's calling m1 method of what? B. Right? So the behavior of this variable is changing based on the type of object assigned. If you see this example like debit card example. Now here RBI is given abstracts to develop which one? Debit card. So banks are developed how many debit cards too? Now SBI is providing which debit card? SBI debit card, and SDFC is providing which debit card? SDFC debit card. Okay. Now where these debit cards are used? Where you use a debit card in ATM. Where these debit cards are used here? In ATM. There is one more object is there. What is that object is there here? ATM. For example, this is which ATM? ICICI ATM. This is which ATM here? ICICI ATM. Now inside ICICI ATM, can I use SBI debit card? Yes. Inside ICICI ATM, can I use SBI debit card or not? Yes. Inside ICICI ATM, can I use SDFC debit card? Yes. Inside ICICI ATM, I can use SBI debit card. Inside ICICI ATM, I can use which debit card? SDFC debit card. It means this ICICI ATM people, they develop the ATM by following the rules given by which one? RBI. So it means these abstracts are used by how many people? Two people. One is implementer and one more is what? Caller. Two people are there here. One is caller is there. This person is called as which one? Caller. And these persons are called which one here? Implementers. Okay, these are called which one here? Implementers. And this is called as which one? Caller. So the caller who want to call these methods of debit card is calling it by following the rules given by which one? RBI. Okay, assume that ATM is having one method called which one? Insert. What do you insert in debit? What do you insert in ATM? Debit card. It is having one argument. And what is the name of the argument here? Debit card. But which debit card? Which debit card? Any debit card. Any debit card, and then I called which method here? Withdraw. I said debit card dot withdraw. But which debit card are you defined here? No. So the behavior of this D changes based on the type of debit card you send it. Suppose if I insert SBI debit card, if I insert SBI debit card in ICICI ATM, then what D is having now? Address of which object here? SBI. Then it will call withdraw method of which one? SBI. Suppose if I insert SDFC debit card, then insert method holding address of which object? SDFC debit card. Then it will call withdraw method of which one? SDFC. Getting on now, this again you call this abstract classes and abstract methods are used to achieve encapsulation. Again, encapsulation. What you are doing, you are hiding the implementations. These implementations are hidden. These implementations are hidden from whom? Caller. The caller doesn't know the implementations. Caller knows only which one? Specifications. Abstracts nothing but what are the abstracts are called here? Specifications. Caller knows only a specifications, like caller knows only a specification. What methods are provided by debit card? Now caller is calling only which one? Specifications at the time of developing, but when actual implementations are revealed at runtime. At runtime is when you send SBI debit card, then it identify this debit card is which one? SBI, and call withdraw method of what? SBI. At runtime, when you insert SDFC debit card, then D is holding a reference of which one? SDFC debit card, and call withdraw method of what? SDFC. So this is called as loosely coupled code. Suppose in future, one more bank introduce one debit card. Is it that debit card will work in ICICI ATM? Yes. Because that debit card also developed by following the rules given by whom? RBI. So it means the implementations can be changed or new types can be added without doing any changes in what? Caller. Without doing any changes in what? Caller. Same thing. If you are working with like Django is a framework, right? Django is a framework. Django is there. What is Django here? Framework. So what this framework will define some abstracts. Okay, now. So this framework will provide some abstracts like how to develop a model, how to develop which one? View. Okay, how to develop which one? Template. Okay, so it will provide abstracts. And using these abstracts, now these abstracts are given by whom? Framework. And there is a developer. Developer develop models by using the abstracts given by whom? Framework. So I develop which model? Student model. I'm developing which model? Employee model. I develop which model? Customer model. I develop all these models by following the rules given by whom? Framework. Then who will execute the functions of these models? This model functions are executed by which one? Server. Okay, which server it is? Django server. So Django server, what Django server is doing? It is calling the functions of which one? Model. Suppose to this Django server, if I give the student model, then Django server calls the functions of which model? Student model. If I give the employee model, then Django server will call the functions of which model? Employee model. But is it Django server is able to call the functions of any model or only one model? Any model. Okay, Django server is able to call the functions of one model or any model? Any model. It is able to execute any view. It is able to execute any model. It is able to execute what? Any template. Why? Because this server is calling which one? The server is calling the methods of abstract or not? Yes. But when actual implementations are revealed at runtime. At runtime. Now this is how generally the framework will work, right? So this is how you develop loosely coupled code. Loosely coupled code here, right? The code which will work with any type, that is called as the same thing you called it as, what is that? Runtime. The same thing is called as a runtime polymorphism. Now, if you see this method, previous example, if you see in this, I am introducing which one? ATM. ICICI what? ATM. Class ICICI ATM. ICICI ATM is having which method? Insert method. And this insert method, what you are inserting in ATM? Debit card. And debit card dot is calling which one? Withdraw. So what you are doing it, you created how many debit cards here? Two debit cards. That is a card one, and one more is what? Card two. And there is also one ATM one. ATM one is there, and is ATM one is which ATM? ICICI ATM. ATM one is which ATM? ICICI ATM. How many cards are there here? Two cards and ATM. Then if I'm saying ATM one dot insert, what you are inserting? Card one. What do you insert here? Card one. So it will call which method? Insert method by sending which one here? Card one. It means D is having a reference of which object? Card one. And card one is an object of which type? SBI. So will it call the withdraw of SBI or not? Yes. But at the time of writing a method, it just called the withdraw of which one? Debit card. At the time of developing this ATM, it calls the withdraw method of what? Debit card. But which debit card? Which debit card? That is revealed at what? Runtime. Which debit card? That is revealed at what? Runtime. So it will call the withdraw method of which debit card? SBI. Okay, now if I say ATM1 dot insert, okay, ATM1 dot, if I'm writing ATM1 dot insert card 2, you send which object, which card you inserted in ATM? Card 2. Now D is having a reference of which object? Card 2. Then D is having a reference of which one? Card 2. Means when I say D dot withdraw, it will call the withdraw method of what? Card 2. But card 2 is which type? SDFs. It means this code is working with any type or specific type? Any type. So that code, you call it as which one? Loosely coupled code. Okay. That code, you call it as which code? Loosely coupled code. Okay. Now, so that is the advantage of using runtime polymorphism. Okay. Insert. I call withdraw. Then I call which method, which function? Main. You can see withdraw which one? SBI. And withdraw which one? SDFC. So this you call it as runtime. Which one is runtime polymorphism? This one is a runtime. So an ability of a reference variable. D is a variable, right? The variable, this is called as a reference variable. The reference variable behavior get changes. The reference variable behavior get changes from one object to what? Another object. Okay, if you assign SDFC, then it behaves like SDFC. If you assign SDFC, ICICI, it behaves like what? ICICI. Okay, so just try to understand here. Okay, right. Right. So it is like this. So this is how your frameworks are designed. It is designed like this only. So there is a caller, there is a specifications, and there is what? Implementations. Specifications, implementations, and one more is what? Caller. Specifications, implementations, and caller will be there. Okay. That is what you call it as APIs, right? API, application programming interface. Carrying on, application programming interface. As a set of libraries or not? Yes. APIs are used for developing applications. Using API, you develop applications. Using API, you can call the functions of developed application. You can develop application, you can call the functions of developed applications using what? APIs. Now your debit card is an API. Using this API, I develop debit card. And using this API, we call the functions of which one? Debit card. We develop debit card and we call the functions of debit card using which one? Debit card API. Okay. Yes. Just try to understand this. For example, if you see another example of this, like, so a lot of examples you can write it on this runtime polymorphism. So import. So which module? ABC module. There is an abstract class. So what is an abstract class here? Sim is there. Sim. Okay. Sim is there. Okay. Your mobile is having what? Sim. But those SIMs are developed by different providers or not? Yes. Airtel is one provider. BSNL is what? One provider. But all these providers will develop the SIMs by following the rules given by. All these SIMs are developed by following the rules given by which one? Who is that? TRAI. Yes or no? Okay. So Telephone Regulatory Authority of India, right? So by following the rules, now these people will give the abstracts. So TRAI says that, okay, every SIM should have which one? Connect. I just take one method only, connect. Every SIM should have which one? Connect. So this method is which method now? Abstract method. This method is an abstract. Connect is an abstract here. And this method doesn't have any implementation. Okay. Then after that, now this mobile SIM providers will be there. No, like which is SIM provider? Airtel. Airtel SIM. They develop the SIM by following the rules given by TRAI. So having a method called which one? Connect. So here you have a logic to connect it to which network? Airtel network. This will connect it to Airtel network. There is another SIM called some BSNL SIM. BSNL SIM is also SIM. And there is a method called which one? Connect. And this will connect it to which network here? BSNL network. This will connect it to which network? BSNL net. So how many types of SIMs are there here? Two types. One is Airtel and one more is what? BSNL. But where we use this SIMs? We use this SIMs inside what? Mobile. So this is one more person who developed what? Mobiles. Mobiles are developed by somebody else, right? And mobile will call the functions of SIM. Mobile calls the functions of which one? SIM. It means even the person who developed a mobile, that person should also follow the rules given by whom? TRAI. Okay, now mobile. So there is a mobile and mobile is having a method. What again? I'll take a method called which one? Insert. So what you insert in mobile? SIM. And once you insert the SIM, then immediately it will connect it to network or not? Yes. Then how it will connect it? By calling a method called which one? Connect. So as a dot, what is that? Connect. So mobile uses SIM and connect to the specific network or not? Yes. But at the time of developing mobile, is it type is there? No. It just uses SIM dot connect. SIM dot connect. SIM dot connect means which SIM? That SIM, which type of SIM? That is known at what? Runtime. When you insert Airtel SIM, then SC is holding which object? Airtel. Then call connect method of which one? Airtel. If I insert in my mobile, if I insert BSNL, then S is having a reference of which one? BSNL. Then call the connect of which one? BSNL. This code is called loosely coupled. But in future, some Geo SIM is there. Can I insert Geo SIM again in my mobile? Yes. That is also having same method or different method? Same method. Same method. Okay, same method. So this is the function main. I create SIM1 is there, and SIM1 which type of SIM here? Airtel. SIM2 is there, and SIM2 is which type of SIM here? BSNL. And then I create a mobile one. Okay, this is a mobile. So I created mobile object, and within mobile object, I insert what first? I insert what here? SIM1. Then this mobile will connect to what? This mobile uses which object? SIM1. SIM1 is which type? Airtel. Then this will connect it to which network? Airtel network. This will connect it to which network here? Airtel network. So once you run this, what is the message? Connected to what here? Airtel network. If I'm trying to insert mobile one dot insert, what I'm inserting here? SIM2. Now I change the SIM1 to what? SIM2. I change the SIM1 to what here? SIM2. But SIM2 is which type? BSNL. Connected to what here? BSNL network. Getting on. Now this you can call it as which one here? Runtime polymorphism. The variable, reference variable behavior get changed based on the type of object assigned. If I assign SIM1, it behaves like what? Airtel. If I assign SIM2, it behaves like what? BSNL. So that code, you call it as which one? Loosely coupled code. Okay. Yes. So this is how you can achieve runtime what? Polymorphism. So it is also called as an encapsulation. Abstract classes also used for achieving what? Encapsulation. So why? Because the person who's calling, right? The person who's calling, caller doesn't know which one? Implementations. Only which one is given to the caller? Specifications. Which one is hidden from the caller? Implementations are hidden. Implementations by just revealing which one? Specifications is called as what? Encapsulation. Hiding. Encapsulation means what? Hiding. Hiding. What is hidden here? Implementations are hidden. This implementation doesn't know by ATM. The implementation doesn't know by what? Mobile. So mobile only uses which one? Specifications. Implementations are hidden. When implementations are revealed at runtime. Implementations are revealed at what? Runtime. Now that you call it as runtime polymorphism. The same thing you called it as which one? Duck typing. The same thing is called as which one? Duck typing. Okay, right? Then next is, so there is, again, you can write a class inside a class, and writing a class inside a class is called inner class, or what is that? Nested class. If you are writing a class inside a class, so writing a class inside a class is called as an inner class, or same thing is called as which one here? Nested classes. Inner classes are what is that? Nested classes. Writing a class inside a class is called as a inner class or nested class. Okay. No overloading. I said no. There is no method overloading. Okay. See, a runtime polymorphism, method resolution order, duck typing, abstract classes. Now this is which classes? Inner classes. Inner classes. So that is writing a class inside what here? Class. Okay, writing a class inside a class. So that you can call it as inner class or nested class. So first of all, what we should know, why we should write a class inside a class. You should know first why we should write a class inside a class. So there are different reasons why we should write a class inside a class. Okay, now there are different reasons why we should write a class inside a class. So different reasons are there for writing a class inside a class. So this is a class inside class is called inner class, or the same thing is called as which one? Nested class. Okay, defining a class inside a class is called an inner class or nested class. So we can define a class inside class with in different situations, right? In different situations or different scenarios or different, what do you call it as, approaches. I mean, when it is used or when to declare, I can say instead of this. So when to declare or when to define a class inside a class. Okay, when to define a class inside a class, when we should define a class inside a class. So there are different reasons. One is hiding. One is what? Hiding implementation of one class. Hiding implementation of what here? Class. You want to write a class, but you want that class to be used by only one class, but should not be used by any other classes. Okay, you want that class should be used by only that class, but should not be used by any other class. Then you write that class inside what? Class. And second one is, what do you call it as? Class. What? Class. So that will avoid code redundancy, writing the same thing again and again. So these are the two reasons why we should write a class inside what? Class. Okay. So here, a class inside a class is called inner class or what? Nested class. Okay. So there are two reasons. Hiding implementation of class, hiding implementation of a class, and one more is class reusability within what? Class. For example, so inner class or nested class, inner class or nested class is used. Inner class or nested class is used within what here? Outer class, but cannot accessible where? Outside the outer class. Inner class or nested class is used where it is used within outer class, but cannot accessible where? Outside the outer class. Okay, that is what you call it as hiding the implementation. Hiding the implementation. So these inner classes, these okay. These inner classes can be, okay, what do you call it as member classes, or it can be what here, local classes. Member classes means which are defined within the class, and local classes means which are defined inside a method. If you write a class inside a method, then it is called as which class? Local class. If you are writing a class inside a class, it is called as which class? Member class. If you are writing a class inside a method, then it is called as which class? Local class. If you are writing a class inside a method, it is called as a local class. Inside a class, if you write, it is called which class? Member class. For example, if I'm writing, so there is a class E. So I'll tell you application. There is a class C and there is a class B is there. Class A is called which class here? Outer class. And class B is called as which class? Inner class. And this inner class is having a method called which one? M1. M1 of which class here? B class. And this outer class is having a method called which one? M2. M2 print. M2 of which class here? A class. So within class A, there is another class called which one? B. And class B is having one method, and class A is having class B as well as what? One method. So M2 is a method of which class? A class. And class B is a class of which class? A class. Okay. So what will happen when I create object of A class? If I create object of A class, it allocates memory for A object, and A object is having how many members? Two members. One is B and one more is what? M2. But is it any, when I create A object, will it create object of B? No. When I create A object, it will not create object of what? B. You have to create object of B in order to access which method? M1 method. I can able to access only one method here. Which method I can able to access? Only which method? M2 method. Now you can see M2 of which class? A class. M2 of A class here. There is a method M2 of A class. But can I call M1 of B class? No. To call this M1 of B class, what I have to do? I have to create object of which class? B class. So where I'm creating object of B class inside A, inside A equal to A dot what is that? B. And this B object is instance variable of which one? A. So it means whenever I create A object, what will happen in this case? Whenever I create A object, so the A object is created by calling which one? Constructor. And within constructor, there is, you are creating a reference variable called which one? B. And this B is holding which object address? B object address. Now this is which object here? B object. This is B object. And this is which object? A object. It means A object is having a reference of which object? B object. Then if I want to call the M2 method of B object, what I'm saying? A object. Suppose if I want to call M1 method of, B object, what should I write here? OBJA, OBJA dot, OBJA is having which object? B object. OBJA dot, OBJB dot, what is that? M1. So A object is having a reference of which object? B object. And you are calling M1 method of which object? B object. But A object is having what method? M2 method. And B object is having which method? M1 method. But where you created B object? You created B object inside which object? A object. So because of that, you are saying OBJ A dot, OBJ A dot, OBJ B dot, OBJ A dot, OBJ B dot. Which method are you calling?